For our story problem, we decided to use a fish. First, it moves horizontally 10 places and up vertically 1. Then with our pink line, we decided to use the second movement as it goes down 10 vertically and has no horizontal movement. Now, this green line that we are drawing is the distance from the beginning and to the end of the movement, and that's the vector that we're solving for. For our first bracket, it is representing the first vector that we drew, or the blue line. The 10 goes on the top and the 1 goes on the bottom. The 10 represents the horizontal movement, and the 1 represents the vertical movement. This is a template that we will continue to use for all vectors. Now we will move on to the pink bracket. The pink bracket represents the pink vector. Since the pink vector does not move any way horizontally, we keep it at 0, and then vertically it moves down 10, so negative 10. The next step is to add those brackets together. So you get the blue bracket, which is our first vector, and the pink bracket, which is our second vector, and add them together to make our green bracket, which is our green vector. So what you would do is you do 10 plus 0, which is 10, so that would go on the top of the new green bracket, and then 1 plus negative 10. And then since a positive plus a negative equals still a negative, it would be negative 9 on the bottom. Now we have to move the two vectors, the blue and the pink, to a different spot to confirm that the green vector is 10 over 9 in the brackets. So we wrote the blue vector at 10 on the y-axis, and then we have to connect the pink vector to the end of the blue vector. Now we are going to count vertically and horizontally to make sure that the green vector is correct. So we go down 9 and horizontally to the right 10, and then connect the line to the 2 points. And that has confirmed that 10 over negative 9 in the brackets is the distance that the fish had traveled in total underwater. We chose to do our video project on vectors because we thought it was interesting how both magnitude and direction could be explained in a bracket form. Vectors are used in both linear algebra and trigonometry, but more importantly, they are used to find the velocity of a moving object. We were interested in how a quantity could express both the magnitude and direction, which forms the velocity of a moving object. When solving vectors, we understood that you need both the magnitude and direction to solve a vector, and having only the magnitude would create a scalar quantity, which focuses on speed. Vectors are important to learn about because if we ever have to solve for the velocity of a moving object, we can use what we learned while doing this project.